If we thought about finding this area under the curve with a bunch of rectangles, in all cases, their width would be delta x, and their height would be here. If we think about what this height is, it's really from the upper curve down to the lower curve. So if this upper curve was, let's say, f of x, and this lower curve was g of x, and we thought about these as just y-coordinates at first. Let's say this is 3, and this y-coordinate is -1. Well, the height would be 3 minus a -1, or 4. If I thought about it more generally, the 3 is really representing the y-coordinate on f, and the -1 is really representing the y-coordinate on g. And so we're going to subtract the upper curve from the lower curve, and that's always going to give you the height of the rectangle. So we've thought about an integral as area. So what we really have is the area equals the integral of my height times my base. And we just said this height right here was the upper curve minus the lower curve. And that's the same thing that the Khan Academy showed, but it didn't really show it as in terms of rectangular area, and I think that can be really helpful. Also, we said that the base of this rectangle was delta x. Well, if we get this small enough, if we have infinitely many rectangles, then this dx is going to go toward 0. It's not 0, but it's getting so small that we call it dx instead of delta x. That's that differential that we've been talking about all year. So now we have the integral from a to b of the height, or f of x minus g of x, times the base, which is dx. In this problem, our lower limit would be -2, and our upper limit would be 2, because we start chopping these rectangles. The very first one we would chop would be over here at -2, and the last one we would slice would be at 2. This -2 and 2 was given to us in the problem, but of course we could have found it by setting these two y's equal to each other. 2x squared equals x to the 4th minus 2x squared. Some factoring would get us the right answers. Subtract 2x squared from both sides. X to the 4th minus 4x squared equals 0. Factoring out an x squared, we have x squared times x squared minus 4 equals 0. Well, our 0 here will be 0. Our zeros here will be x minus 2, x plus 2. Well, that's where the 2 and the -2 come from, setting each of these factors equal to 0. Okay, so now we've got our limits. But I said that there was a shortcut with this video, and so here I'm going to talk about that shortcut. Whenever we're finding the area between two curves, we can always think about just the upper curve minus the lower curve. And so my upper curve is 2x squared, and my lower curve, in parentheses, because this is one entire curve, is x to the 4th minus 2x squared. All of this is multiplied by our base of dx. And I could go from -2 to 2. But it's going to be simpler when I do this by hand if I could have a 0 plugged in, because that way when I try to evaluate my lower limit, everything is 0. And hopefully you can see with symmetry, these two areas are exactly equal. this green area is symmetric with this yellow area. And so instead of going from -2 to 2, I could turn around and say, I'm just going to look at the green area. The green area goes from 0 to 2 with all of my rectangles that I could draw. And so instead of going from -2 to 2, if I go from 0 to 2, I just have to remember that this area is the same as this area. So I could turn around and double my result. And there is the shortcut. I'll distribute this negative through to both terms, and then I'll combine my like terms. 2x squared and another 2x squared gives me 4x squared. Now I'll find my antiderivative. 4x cubed over 3 minus x to the 5th over 5. But now we can evaluate this from 0 to 2 instead of -2 to 2, and we're going to double the entire result. So now as I keep going, we really have 2 times 4 times 2 cubed over 3 minus 2 to the 5th over 5. But the nice thing is minus 0, because when I plug zeros in for all these x's, I have nothing. And so that oftentimes helps, because I don't really have to evaluate the second half of this integral. When I simplify some of this arithmetic, 2 cubed is 8, 2 to the 5th is 32, and I'm going to double this entire result. So we really have 2 times 32 over 3 minus 32 over 5. I can see I need a common denominator of 15. So the first gets multiplied by 5. The next gets multiplied by 3. Continuing on with symmetry, we have 2 times 160 minus 96, which is 64. 2 times 64 is 128. Over my denominator of 5.